Hello, everyone. Welcome to this conversation about sharing real-time status of military operations areas and restricted areas with users of our national airspace system. I'm pleased that the FAA and the Department of Defense have continued a long history of collaboration to jointly present this opportunity to share government and industry perspectives and challenges regarding implementation of Section 1085 in the 2021 National Defense Authorization Act. As you know, in Section 1085, Congress asked us to give pilots and other members of the public the ability to check in real time whether a military operations area or restricted area is in active use, or if it's available to fly through. This initiative doesn't change the frequency with which military airspace becomes available, but it will make information about that airspace more accessible and useful. While traveling in our airspace today, pilots can always ask air traffic controllers if transit through military airspace is available, but they can't access the information in an automated format that's available NAS-wide. Many of you in industry have expressed that it would benefit you more to have real-time access while you are flight planning or operating in the cockpit. We share your hope that providing this information will help everyone maximize the use of airspace safely and efficiently. We're always in favor of gaining efficiencies in traffic flow if it can be done safely. Turning data into useful information to improve safety has been a top priority of FAA Administrator Steve Dickson, and I think this is another opportunity where data transparency can benefit our national airspace system. My team, along with our DoD counterparts, have begun taking the steps necessary to implement access to real-time status of restricted and military operations areas. I meet routinely with the Executive Director of the DoD Policy Board on Federal Aviation, who is an executive in the Air Force, to discuss our progress on this and other matters. One measure we have taken is to form a joint FAA-DoD Tiger Team and subgroups to research potential paths forward. This team is actively evaluating options of how to provide information on military operations areas and restricted areas to all NAS users. I wish the data was something that we could simply upload to the cloud with a push of a button, but it's proving to be a bigger challenge. The information is nested in a very complex data architecture system spanning FAA and DoD, so it's going to take some time to determine the best way to extract it. We don't have a solution yet, but DoD and the FAA are working side by side. And together, we understand there's another important step that must run in parallel. Once you get the information, you'll need a way to use it. While you're counting on us for the data, we're counting on industry for technical solutions so that you can display and utilize the information easily in the flight deck or elsewhere. You'll need the right avionics, equipment, application, or tool to access the data in real time once we make it available to you. That's why I'm glad that you're all here to take this opportunity to share your ideas and perspectives and ask questions following our presentations. We're all looking forward to hearing more about what you as stakeholders need to make this effort successful. We will all get a better product if we're transparent about our needs now. Before I turn this over to my DoD colleague, I do want to take a moment to remind everyone that this effort will only be successful if we maintain our national security and protect military airspace. We've designated special use airspace for a reason, to segregate military training activities from other air traffic. The men and women who defend our nation use military operation areas to practice combat tactics, air intercepts, formation training, and other important maneuvers. In restricted areas, there can be hazards to aircraft such as artillery firing, aerial gunnery, and guided missiles. So we hope that the transparency of this initiative will lead to enhanced awareness of when to avoid restricted airspace. This information must be used smartly and securely, and I know that we can count on you to join us in ensuring that that continues to be the case. I also want to take a moment to give a shout out to the military controllers who guide so many civilian aircraft through the skies. We know the role that you play, even if passengers may not. They control traffic in busy and complex geographic areas over many miles of airspace. So thank you. Next, you're going to hear from Brigadier General Matthew T. Mowry of the Department of Defense, who's an Assistant Deputy Commandant for Aviation with the Marine Corps. Have a great meeting, everyone. Thank you.
Good morning, and many thanks to Ms. Terry Bristol for that introduction. I am Brigadier General Matt Mowry, Assistant Deputy Commandant for Aviation, United States Marine Corps. It is with pleasure that I accepted an invitation from the Department of Defense Policy Board on Federal Aviation, or PBFA, to provide opening comments for this joint FAA, DoD Industry and Stakeholder Day. It's not often I get to connect with such a diverse group of aviation stakeholders, all interested in improving the efficiency, effectiveness, and safety of the strategic resource known as the National Aerospace System. Let me start by saying thanks to the leadership in the FAA and the PBFA, as we are currently experiencing the most collaborative and cooperative environment between the FAA and DoD in many years. As proof, I offer the fact that both organizations are party to a 2020 Memorandum of Understanding focused on specific joint efforts toward the modernization of the National Airspace System. One of the main goals in the MOU is to develop special activity airspace process improvements and policy amendments to promote compatibility and to establish a long-term National Airspace System strategic plan that effectively accommodates all NAS users. With those key facts in mind, I'd like to take this opportunity to speak to you from not only a marine aviation leadership perspective, but more broadly from a joint service and DoD point of view. The Marine Corps and our sister services have installations throughout the U.S. with operational units who have training requirements that require special use airspace that is usually associated with ground training ranges, aviation ranges, or a combination of both. Let me provide you two Marine Corps examples to illustrate this. Camp Pendleton is located between San Diego and Los Angeles on the Southern California coast and is home to the 1st Marine Expeditionary Force and has both an air station and surrounding restricted airspace that overlies training ranges. This training complex is ideal for the Marine Corps to maintain our warfighting readiness by conducting combined arms training and integrated amphibious operations with aviation support in a live fire environment. This environment is essential to test, modify, update, and strengthen our amphibious doctrine and emerging strategies, such as a concept known as Expeditionary Advanced Base Operations. EABO revolutionizes amphibious operations to once again integrate the Marine Corps within the larger naval campaign in order to maintain superiority over our adversaries. Another example of a Marine Corps training complex is the desert of 29 Palms, California. Many of you may be familiar with the restricted area that overlies this area. In fact, in today's presentation, you will be provided with some graphics of the restricted area and the associated training ranges. The Marine Corps Air-Ground Combat Center can be considered the premier training base for the Marine Corps, as we have recently expanded the land which was required to accommodate large-scale exercises. In both examples, it is urgently important the Marines train like they fight. You may have heard this saying, but throughout the DoD, it is not cliche. It is imperative to create conditions that closely resemble those in combat in order to properly train, protect, and prepare our soldiers, sailors, airmen, space guardians, and Marines for battle. Also, in both these examples, the training ranges and restricted areas are located in the vicinity of high-traffic civilian air routes for both commercial and general aviation. In the case of Camp Pendleton along the Southern California coast, with the north-south traffic of San Diego and Los Angeles, and in the case of 29 Palms situated in the eastern portion of the LA basin, where westbound commercial aircraft begin their descent into the Los Angeles area, while northbound aircraft depart from Palm Springs. In these and all other locations, the Marine Corps and the entire DoD is committed to share and manage the airspace in the most efficient, effective, and safe manner to accommodate the needs of civil traffic and at the same time achieve our national defense requirements. Like the Marine Corps, each service has its own unique national defense mission and training requirements. Special use airspace in the vicinity of our installations is a vital resource to meet training and readiness requirements. Where our training overlaps or complements the joint DoD team, we make a concerted effort to share our special use airspace for efficiency and effectiveness of our training. In summary, I will again express my appreciation for the opportunity to address this diverse gathering of aviation stakeholders. I hope you stay with us for the presentations and Q&A session. The DoD and FAA will continue our joint efforts to achieve the goals expressed in our recent Memorandum of Understanding, and my hope is that this forum helps our fellow aviation stakeholders increase their education and trust in our stewardship of the national airspace system. Thank you.
Good morning. My name is Scott Rosenblum, and I'm with the Federal Aviation Administration's Air Traffic Organization. Alongside my colleagues at the Federal Aviation Administration and our partners at the Department of Defense, I'd like to welcome you to this Industry Day on Special Use Airspace Status. The purpose and goals for today's event are to provide education about special use airspace, to share perspectives, and discuss challenges faced by government and industry regarding the fiscal year 2021 National Defense Authorization Act, Section 1085, Deployment of Real-Time Status of Special Use Airspace. Section 1085 states, in summary, that the FAA, in coordination with the DoD, shall enable the automated dissemination of the real-time status of special use airspace, specifically military operations areas, commonly known as Moas, and restricted areas. As previously mentioned in our welcome remarks, the FAA and DoD have a long history of collaboration, and we have taken steps to begin implementation efforts for this legislation. To achieve this, we established a Tiger team and sub-teams to research and address the policies, procedures, and technologies required to provide the real-time status of special use airspace directly to national airspace system users. Our research revealed that implementation is a bigger challenge, and any proposed solution will be more complex than the legislation envisioned. We understand the desire to have accurate, on-demand data. Unfortunately, it's not as easy as turning on a faucet. The complexities of the airspace data and the data architecture design housed in both the FAA and DoD systems are challenges we will have to work through together to find integrated solutions. And while you're relying on us to provide accurate and on-time data, we're relying on industry for technical solutions to display and utilize the information directly in the cockpit or elsewhere. We're looking to industry to identify the right avionics, equipment, application, or tool to access the data in real time once we make it available to you. Our Tiger team heard and understood the request and has been hard at work already identifying a potential short-term solution to disseminate MOA and restricted area status utilizing Flight Information Services Broadcast, commonly known as FISB. We'll be discussing this interim solution in depth later today. Our format for today's event will begin with a series of presentations from FAA and DoD subject matter experts in the areas of special use airspace policies and procedures, airspace data sharing today and future challenges, special use airspace flight operations today, and finally, current and future airspace data dissemination. Following these presentations, industry and public participants will engage with a panel of FAA and DoD subject matter experts through a live question and answer session. Through this panel, we hope to answer your questions, share perspectives, and hear from industry about your challenges. We recognize that there's much work to be done by both government and industry in order to implement this legislation. This event is the first step in engaging with industry, and we look forward to continuing the conversation as we collectively work towards solutions. Thank you.
Good morning. My name is Colby Abbott, and I'm an airspace specialist on the FAA's Airspace Rules and Regulations team. Today, I will present an introduction to special use airspace to share what it is, some FAA policies that govern it, and how it's used to ensure the safe and efficient use of the National Airspace System, or NAS. To do that, I'll show how the FAA defines special use airspace and the purposes it serves, address a few special use airspace related terms, and highlight FAA airspace policies that govern the design and use of special use airspace. I'll mention the types of special use airspace the FAA oversees, but we'll focus on restricted areas and military operations areas, or MOAs. And we'll finish with a quick look of how restricted areas and MOAs are depicted on visual flight rules or VFR sectional charts for pilot awareness and planning. But first, let's address where the FAA draws its authority to manage airspace within the NAS. The FAA draws its authority to manage the use of airspace from Title 49 of the United States Code, Section 40103. That section establishes the federal government's exclusive sovereignty over the airspace of the United States, and that each citizen of the United States has a public right of transit through the navigable airspace. But it's this section that also charges the administrator of the FAA with the responsibility to manage the airspace of the NAS. The administrator oversees all plans, policies, regulations, and orders for the safe and efficient use of navigable airspace within the NAS. The administrator also establishes security provisions to allow the maximum use of navigable airspace by civil aircraft, consistent with national security requirements. In consultation with the Secretary of Defense, the administrator establishes areas within the navigable airspace deemed necessary in the interest of national defense. Those areas are special use airspace. The FAA defines special use airspace as airspace with defined dimensions wherein activities must be confined because of their nature or limitations may be imposed on other aircraft that are not part of those activities, or both. The primary purpose of special use airspace is to establish airspace areas supporting the military's national defense and security mission requirements. Depending on the activities conducted, the FAA may establish special use airspace that either confines hazardous activities or segregates non-hazardous activities in defined areas from other airspace users. Charted special use airspace identifies where military activities are occurring for other airspace users' awareness. The FAA establishes special use airspace to support existing or known future military airspace requirements. Special use airspace is not established for undefined purposes. In discussing special use airspace, it's helpful to know what controlling and using agencies are, as well as participants and non-participants. The controlling agency is the FAA Air Traffic Control Facility that controls the airspace when the special use airspace is not active. However, a military air traffic control facility may be assigned as the controlling agency if the FAA agrees. The using agency is the military unit or other organization whose activity established the requirement for special use airspace. The using agency is responsible for ensuring special use airspace is used for its designated purpose, establishing scheduling procedures and using them, and keeping the controlling agency informed of all changes. A participant refers to the aviation or ground-based users that are participating in the activities special use airspace is scheduled and activated for. Lastly, a non-participant refers to all other airspace users that are not participating in the activities special use airspace is scheduled and activated for. Equally important to the previous terms are those that describe when and how a controlling or using agency can use a volume of special use airspace. Published times or times of use reflect the time periods a using agency may schedule a special use airspace. These times are part of the special use airspace description. Scheduled times are the time periods within the published times of use that a using agency plans to use a special use airspace area. Activated times are the time periods that the controlling agency releases scheduled special use airspace to the using agency for use by the scheduled participants. And lastly, utilized times are the time periods that the aviation or ground-based participants are actually using the activated special use airspace. In Mr. Ibe's presentation following shortly, he will provide a scenario that demonstrates the relationship of published, scheduled, activated, and utilized times. To manage the safe and efficient use of airspace and support the military's national defense mission requirements, the FAA oversees 7 types of special use airspace. Each type supports a different purpose. Prohibited areas and restricted areas are regulatory or rulemaking actions that the FAA accomplishes by formal amendment to Title 14 of the Code of Federal Regulations in Part 73. Moas, warning areas, alert areas, controlled firing areas, and national security areas are other than regulatory or non-rulemaking actions that, except for controlled firing areas, are accomplished by publication in the National Flight Data Digest. Controlled firing areas are established by letter of agreement between the using and controlling agencies. Today, however, we're addressing restricted areas and Moas. First, though, let's look at a number of FAA policies aimed at special use airspace design, use, and aerial access to maximize airspace safety and efficiency and minimize adverse aeronautical impacts. The FAA accomplishes aeronautical studies when special use airspace proposals are received to fully consider and balance the military's requirement with any identified aeronautical impacts on non-participating aircraft and air traffic control operations. The FAA mitigates impacts when able and minimizes them when unable. To further minimize aeronautical impacts, special use airspace dimensions and times of use must be the minimum required for containing the proposed activities, including safety zones required by the military. Similarly, special use airspace must only be scheduled and activated when required. During periods when activated special use airspace is not required, it should be returned to the controlling agency for use by non-participating aircraft. And to ensure optimum use of airspace, military using agencies must, where mission requirements permit, make their assigned special use airspace available for other military units on a shared use basis, consistent with its designated purpose. The FAA's joint use policy requires the using agency to return special use airspace to the controlling agency when not needed for its designated purpose. This policy is aimed at maximizing the use of airspace, which is a finite resource for all airspace users. In support of that, the FAA requires restricted areas and Moas to be designated as joint use to the extent possible. Joint use procedures must be specified in a letter of agreement between the using and controlling agencies and include provisions for real-time activation and deactivation, if able, and timely notifications when scheduled activities change, cancel, or are complete. If included in the letter of agreement, the controlling agency may route VFR or Instrument Flight Rules or IFR aircraft through activated special use airspace as long as it is safe to do so. Finally, using agencies are encouraged to subdivide large special use airspace areas. This provides the ability to schedule and activate in real time only the portions of special use airspace needed for military requirements, while allowing the use of unscheduled portions by non-participant aircraft. To ensure aerial access to airports underlying restricted areas and Moas by non-participating aircraft, These volumes of special use airspace must exclude the airspace 1,500 feet above ground level and below within a 3 nautical mile radius of the airports available for public use. This exclusion may be increased if necessary based on unique circumstances. Likewise, provisions must be made to allow non-participating aircraft aerial access to private and public use lands beneath the restricted areas and Moas to enable terminal, VFR, and IFR flight operations. And for establishing restricted areas today, the floor of restricted areas may only be established to the surface when the using agency either owns, leases, or by agreement controls the underlying surface. With restricted areas, they're established to confine or segregate hazardous activities from non-participating aircraft and restrict the non-participating aircraft from entering the restricted area. The boundaries and altitudes are determined by the hazardous activities being conducted. These activities could be from aviation or ground-based participants and may not be visible to non-participants. Restricted areas are not established for non-hazardous activities or for activities that benefit an individual or commercial operator over the public's right of transit in navigable airspace. Temporary restricted areas may be established to accommodate military requirements for additional airspace to conduct hazardous activities during short duration exercise or test programs. Due to their temporary nature, temporary restricted areas are not charted. Instead, the FAA publishes a rule in the Federal Register to inform the public. Additionally, the FAA publishes a graphic notice of the temporary restricted area in the domestic notices portion of the Air Traffic Plans and Publications webpage and on the FAA's Special Use Airspace webpage. Typical hazardous activities conducted in restricted areas may include, but are not limited to, air-to-ground firing, artillery, airborne or ground-based non-eye-safe laser operations, or aerostat balloons with unlit tethers. Here's an example of charted restricted areas. The restricted area 3008 complex next to Moody Air Force Base near Valdosta, Georgia. Restricted areas are depicted on VFR sectional charts in blue ink, with blue hashed markings highlighting the boundary of the restricted areas or complex. In this depiction of the R3008 complex, highlighted in blue, it appears as a two-dimensional figure reflecting only the lateral boundaries of the complex. However, special use airspace is a three-dimensional volume of airspace with a vertical component defined by floor and ceiling altitudes. Pilots can determine the altitudes for special use airspace areas by using the special use airspace table that's published in the margin of each VFR sectional chart. In addition to the altitude information, pilots can view the published times of use for each volume of special use airspace. These times define when the using agency may schedule that volume of airspace. Using the two-dimensional charted view of the R3008 complex and the associated altitude information listed in the table, non-participating pilots can determine what airspace to avoid when the special use airspace is active. Additionally, using the times of use information in the table, non-participating pilots can determine when the restricted area complex cannot be scheduled and when they may fly through the airspace in that area unobstructed. In the case of Moas, they're established to contain non-hazardous activities and do not extend into Class A airspace. They separate non-hazardous activities from IFR aircraft, and for VFR aircraft, identify where the non-hazardous activities are. VFR aircraft are not denied access through active Moas, but IFR aircraft may only be routed through active Moas as contained in the letter of agreement between the using and controlling agencies. This letter of agreement establishes the procedures to ensure separation from the military activities. Temporary Moas may also be established to accommodate the military's need for additional airspace to conduct short duration exercises. Similar to temporary restricted areas, these areas are also not charted. Instead, the FAA publishes a graphic notice of the temporary MOA in the domestic notices of the Air Traffic Plans and Publications webpage and on the FAA's Special Use Airspace webpage. Typical non-hazardous activities in MOAs may include, but are not limited to, air combat maneuvers, air intercepts, or low altitude tactics. Here's an example of MOAs adjacent to the restricted area R3008 complex. MOAs are depicted on VFR sectional charts using magenta ink with magenta hashed markings highlighting the boundaries of the MOAs. In this depiction of the Moody 2 North and South MOAs, highlighted in magenta, you'll again notice they appear as two-dimensional figures, reflecting only the lateral boundaries of the MOAs. Like the previous R3008 example, the Moody 2 North and South MOAs are three-dimensional volumes of airspace with a vertical component. Just like restricted areas, the altitude information for the MOAs are published in the Special Use Airspace table included on the VFR sectional charts. Additionally, the published times of use the MOAs may be scheduled are also listed in the table. As mentioned with the restricted area R3008 example, non-participant pilots may use the two-dimensional charted view of the Moody 2 North and South MOAs, accompanied by the associated altitude information in the table, to determine the MOA's dimensions when active. And again, using the times of use information listed in the table, non-participating pilots can determine when the MOAs may not be scheduled and they may fly through the airspace in that area. Restricted area and MOA's published times of use represent when the areas may be scheduled, and the scheduled times only represent when a using agency plans to use them. It's the activation times that reflect when the special use airspace areas are active. And it's that real-time activation information that the FAA and DoD are working together on to share with all airspace users. In this presentation, I covered a high-level description of special use airspace, some design considerations, and use cases for restricted areas and MOAs. Recall that special use airspace supports our military's national defense mission requirements, confines or segregates military activities from other airspace users, and identifies for non-participants where those activities occur. Additionally, I reviewed the FAA's special use airspace policies for design, use, and aerial access aspects to minimize impacts on non-participating aircraft. Lastly, I explained the need for restricted areas and MOAs and where pilots may find some information. Restricted areas are established to contain hazardous activities, whereas MOAs are established to contain non-hazardous activities. I also provided an example of how a VFR sectional depicts each special use airspace type with boundary, altitude, and times of use information. Thank you for participating in today's FAA DoD Industry Day activities.
Hello, I'm Lieutenant Colonel Joe Turkle, and I'm the Marine Corps Liaison to the FAA, and currently the Department of Defense co-lead for Tactical Management of Special Use Airspace Tiger Team. Today, I'm going to be providing a brief overview of the Department of Defense airspace policy and provide a few examples of restricted areas associated with training ranges. I'll then turn it over to my colleague Eric from Headquarters Air Force to talk about the systems DoD has in place to clear our schedules with the FAA. Lastly, we'll provide an animated scenario to demonstrate how the DoD schedules and utilizes special use airspace. As we all know, navigable airspace is a limited natural resource, and as such, it needs to be managed both safely and efficiently. In carrying out that responsibility, it is the DoD's policy to ensure that only the minimum amount of airspace is used for our activities. Activities that range from surface-to-surface fire, such as artillery, to air combat maneuvers. When that airspace is not needed by the DoD, it is released to the controlling agency and becomes available for all users. This joint use concept is in action at our air and ground ranges. These ranges serve to train the military for combat and to maintain a level of proficiency and combat readiness. You may often hear the military needs to train as we fight. The training often includes a mix of various weapon systems from diverse flying platforms, as well as a multitude of ground weapons such as tanks, artillery, lasers, and rockets. Regardless of the weapon system in use, they all need a volume of protected airspace known as restricted area to ensure these activities can be conducted safely. This is an example of restricted airspace that overlies the range complex at 29 Palms, California. The DoD often makes the greatest attempt to divide restricted areas into multiple sub-areas that can be activated or deactivated all at once or independently, depending on the training and the mission. This allows for the most efficient use of the national airspace system, at the same time achieving DoD training requirements and in keeping with DoD policy to keep the dimensions and times of special use airspace to a minimum required in order to contain the proposed activities and to limit the impact on all other national airspace users. This is the same area, but displays the number of training ranges that are contained within the restricted area. This graphic depicts how multiple ranges can be active and how restricted area would be activated if all the training ranges were being used at the same altitude. In this case, all hazardous activities would be maintained below this ceiling, and it will allow for the controlling agency to retain the airspace above the ceiling for non-participating aircraft use. This example depicts a more frequent scenario where different ranges are scheduled to different altitudes. In this example, because the restricted area is divided into sub-areas, the controlling agency would be able to retain different areas to lower ceilings for the most efficient use of the airspace. In this last example, because of the complexity of training and the dynamic scheduling of various ranges, the using agency and controlling agency may again choose to create a single ceiling over the entire restricted area and utilize the airspace above for non-participating aircraft. In all three of these scenarios, we see how creative scheduling of airspace can allow the DoD to achieve its training objectives while also accommodating the transit of non-participating aircraft. You may be wondering how non-participants know when this airspace is going to be scheduled. For that answer, we need to look at the various systems and methods the DoD uses to communicate its daily airspace requirements to the FAA. And now, over to you, Eric.
Good morning, everyone. My name is Eric Ibe, and I'm an operations research analyst working for Headquarters Air Force. And today I'm going to be providing a brief overview of the various systems and methodologies the DoD has in place to share our airspace schedules with the FAA and ultimately the rest of the users of the NAS. I'm also going to walk you through an animated scenario which puts some of the terminology discussed earlier into better perspective. Terms such as scheduled, activated, utilized, and how they affect the status of airspace should become more clear. So let's jump right into it. Starting at the bottom of this diagram, we can see that each service submits their daily airspace requirements through an application tailored to meet each service's individual scheduling needs. In this case, we can see that the Air Force uses a system called CSE, Navy uses DCAST, and the Army and Marines use RFMIS. Though different systems with capabilities unique to each service, they all provide their airspace scheduling data, such as times, type and number of aircraft, etc., to the FAA via a software interface with an FAA system called NAID-SAMS. Those schedules are then consolidated and become available to the controlling agency, which in most cases is an FAA ATC facility such as a center or TRACON. DoD airspace schedules are also made available by the FAA to the rest of the NAS through their public-facing website, sua.faa.gov. With this data now in hand, the FAA will activate the airspace in accordance with the scheduled times received from the DoD. Now let's take a minute to walk through an animated scenario of special use airspace at work. In this case, a military operating area and a restricted area. Here we see a good representation of special use airspace designed to support the operations of a local unit. In this case, we have an excerpt of a VFR sectional for South Central Georgia with Moody Air Force Base in the center left of the screen, with restricted area 3008 directly to the east and Moody Moa 2 north and south to the east of that. As Mr. Abbott explained in the previous topic, the published times and altitude stratums for each of these airspaces can be found within the VFR sectional itself, as represented here with restricted area 3008 and the same here with Moody 2 north and Moody 2 South Moas. Now we get to the schedule times. And for that, you would need to reference sua.faa.gov, which will tell you exactly which pieces of special use airspace are scheduled to be in use for the next 24 hours. And in doing so, you can see a textual description like what is pictured here. sua.faa.gov will also provide a graphical representation like what I have depicted here, although it will be in a different color. I have the airspace colored green solely for the purposes of this presentation so that there's a clear distinction in SUA status as I progress through the scenario. At 0800, that airspace is going to be activated in accordance with the schedule submitted by the DoD, meaning that the controlling agency, which in this case is Jacksonville Center, is going to release control of the airspace to the using agency, which is Moody Air Force Base Radar Approach Control. Once that airspace is activated, then those volumes of airspace assume the restrictions and controls associated with special use airspace that was explained earlier by Mr. Abbott. Meaning, non-participating IFR traffic must avoid both the restricted area and the MOA. While VFR traffic will have to avoid the restricted area, they can legally transit the MOA. Airspace activation times won't be found on sua.faa.gov, but they do typically correspond to the scheduled times. Once the airspace is activated, then the airspace protections inherent within each are in effect. In this case, we have a flight of A-10s departing Moody Air Force Base who are going to be conducting training within the confines of Restricted Area 3008, Moody 2 North, and Moody 2 South MOAs. As soon as those A-10s cross the border of the activated airspace, then that airspace is considered being utilized, meaning there are now aircraft physically within the confines of the activated airspace. In this example, we see A-10s conducting operations in the MOAs, but then transitioning into the restricted area to conduct live fire activities on the range, which resides within the confines of Restricted Area 3008, and then transitioning back out into the MOAs. So depending on the profile of the training event taking place, there may be an opportunity to transition non-participating aircraft through an activated volume of special use airspace that is being actively utilized. There are also times when the airspace must remain active even without aircraft or ground fire activities being conducted, simply because the time in between events is not long enough to warrant deactivating the airspace and returning it to the controlling agency. For example, if the flight of A-10s are done with their training event and have returned to Moody, but the next flight of aircraft are expected in the next 15 minutes, then that airspace is likely going to remain activated. However, this does not preclude the possibility of non-participating aircraft transitioning through the airspace during that small window of time if properly coordinated real-time with ATC. Knowing the difference between scheduled, activated, and utilized is critical when it comes to having a complete understanding of how the joint use concept is actually applied when non-participating aircraft need to transit that airspace. An example of how the FAA applies that concept can be seen in a short animation coming up in the following briefing by Mr. Steve Homelman. Thank you.
Good morning. My name is Steve Homelman, and I work in Air Traffic Services at FAA headquarters under the Director of Operational Policy and Implementation. Previously, I've worked at Chicago Center for 30 years, the last 5 years in the Traffic Management Unit, or TMU. My presentation is on flight operations today and what air traffic controllers do to safely and efficiently move aircraft around a special use airspace, or SUAs or SUAs. A few key takeaways from this presentation will include the difference between how IFR and VFR aircraft are handled around SUAs, the different services a controller can provide a VFR aircraft that has requested flight following, what tools an air traffic controller has for the separation of an aircraft from the active special use airspace. Just like pilots, controllers need information about a special use airspace and its activation. This includes advance notice that the special use airspace will be going active, what time the SUA is officially activated, what altitudes are in use by the SUA, and the expected time the airspace will be deactivated. Controllers in general don't really care if there are aircraft in the SUA. They really just want to know the SUA status, either active or inactive. As long as controllers have this information in a timely fashion, we can plan traffic patterns and coordination efforts accordingly. To help demonstrate how controllers work around and work with special use airspace, we've prepared a few simulations. But first, let's go back to the last simulation from the previous discussion. Here, you'll see the VFR sectional chart with Moody 2 North and South Moas highlighted, and also the R3008 restricted area complex, which is composed of R3008 Alpha, Bravo, Charlie, and Delta. To make things easier, I'll refer to it as the R3008 complex and as the Moody 2 Moas. But even this map is complicated. So let's change the map to be the en route low altitude map so we can more easily concentrate on what's important for this presentation. The R3008 complex, Moody 2 Moas, Victor Airways around the active SUAs, nearby airports, and navigational aids that are in the vicinity. All the other details within the sectional chart are important, but for this discussion, they are not pertinent. Now that we've switched displays, you can see Moody Air Force Base, Kilo Victor Alpha Delta, is immediately left of and adjacent to the R3008 complex. Valdosta Airport, Kilo Victor Lima Delta, and Valdosta Vortec, Oscar Tango Kilo, are just southwest of the SUA, and Waycross Airport, Kilo Alpha Yankee Sierra, is to the northeast. This first simulation will show what a normal VFR flight from Valdosta to Waycross will look like, as indicated by the highlighted route. However, when a VFR aircraft is departing, especially from a towered airport, we can inform the pilot of the active SUA and issue vectors around the R3008 complex, as indicated by the blue route, knowing that the flight is still allowed to fly VFR through the Moody 2 Moas. And if the pilot has requested VFR flight following, the controllers working that airspace are obligated to provide safety and traffic advisories, even within the SUA. And the controller will help the pilot avoid SUAs they are not permitted to enter, such as a restricted area. If the aircraft is squawking VFR or on a 1200 code, then no advisories will be issued. This next simulation shows how air traffic control adjusts an IFR aircraft's flight plan to avoid the active SUA. Remember, because the SUA is active and it's an aircraft operating under IFR rules, controllers will reroute the aircraft around the Moody 2 MOAs. This simulated flight is planned to transit from the southwest and proceed northeastbound over Valdosta, go through Waycross, and eventually proceed northeast to Savannah, Georgia. In this instance, the controller saw the aircraft proceeding directly towards the active SUA. The controller would then issue a new route around the SUA, in this case, direct Valdosta, then Victor 579 to Macon, Victor 578 Alma, direct Savannah. This routing takes the aircraft around the SUA to the west and north. Depending on the conditions and the pilot's preference, the controller also has the option to take the aircraft to south around the Moody 2 Moas and then direct Savannah when clear. The controller also has the option to vector or turn the aircraft around the SUA. However, many controllers don't prefer this option because it can greatly increase their workload. By choosing a viable airway-to-airway or point-to-point route around the airspace, the controller can limit their workload and also limit the worries a pilot may have about missing the active special use airspace. Our last example shows what may happen with the departure off Jacksonville, Florida, Juliet Alpha X-ray, which is in the lower right corner of the display. The aircraft is filed Jacksonville, the Jacksonville 7 Standard Instrument Departure, or SID, and Direct Dawn intersection, which is displayed. Since the aircraft hasn't departed yet, and it is known that the SUA is active, controllers can reroute around the SUA before the aircraft departs, enabling the pilot to check fuel status and flight conditions before departure. The issued reroute is now displayed, taking the aircraft over Greenville VOR, Golf Echo Foxtrot, before reconnecting with the expected route over Dawn intersection. In this instance, Greenville may actually be a little farther west than expected, but Valdosta Vortac is a known very busy waypoint for flights to Southern Florida. So the route got extended west to allow the aircraft a much less impeded climb out. Don't forget, the controller may shortcut the aircraft direct Dawn intersection depending on traffic conditions. The pilot can also ask for the on-course turn when they feel they are clear of the SUA. And in this example, if the aircraft has climbed above the active SUA, the aircraft may also ask for the on-course turn. In conclusion, here are a few takeaways from this part of our presentation. Remember, contact Air Traffic Controller ATC. If you don't communicate with us, we can't provide traffic alerts or help you avoid no-fly zones. Don't forget, VFR aircraft can enter certain types of SUAs, and controllers are not out to punish you. When there is an active special use airspace, there are certain rules both ATC and pilots must adhere to. If a controller is trying to vector or reroute an aircraft, they've got a pretty good reason. And don't forget, they are required to tell you the purpose of the reroute or vector. And if they don't tell you why, don't be afraid to ask. I want to thank you for your time, and I look forward to answering your questions in the live chat later in the presentation.
Our next topic is data sharing and dissemination. For this segment, we are joined by Andy Leone, Davey Andrew, and Alex Murray of the FAA's Program Management Organization. The purpose of this topic is to recap where we are with data dissemination today and present two potential future pathways for data dissemination. To do this, Andy will present FISB, or Flight Information Services Broadcast. Davey will present AIM ACS, as defined on the slide. And Alex will present SWIM, System-Wide Information Management. As a reminder, always contact Air Traffic Control for the status of all special use airspace. As a recap from earlier presentations, you can see how individual DoD scheduling systems interact with the FAA's MAID SAMS system and how that data ends up on sua.faa.gov to be used for flight planning and potentially notices to airmen, in addition to air traffic control communication. Potential future data pathways are displayed here. FISB has the potential to get this information directly into the cockpit, whereas the other pathway could be AIM ACS via SWIM into the cockpit. With that, Andy, over to you.
Good morning. My name is Andy Leone. I'm with the FAA SBS Program Office, Systems Engineering Lead. Today, I am going to go over FISB and the SUA status products that are provided under FISB. On our first slide here, the FISB service is a broadcast service provided only over the 978 megahertz UAT link, where weather and aeronautical information is uplinked to equipped operators. The FISB ConOps, or concept of operations, is that a single radio station provides a specific set of data products at a specific update rate with a specified look-ahead range through a fixed set of UAT ground uplink slots or channels that are applied over the 978 megahertz link. An ADS-B in UAT equipped aircraft that captures all of the allotted slots from a single radio station would be able to provide a set of data representing the weather and aeronautical conditions and NAS status information in the surrounding area. We are highlighting on this slide the 16 current products offered by the FISB service, and also providing in the lower right-hand corner current equipage levels throughout the NAS. Although not listed here, just for reference on the ADS-B out equipage, it's roughly 173,000 targets. But out of that, the population of targets that are ADS-B in equipped is around 120,000, with around 110,000 able to receive across the UAT link, or hence FISB data. On this next slide, we're showing that the FISB service is receiving the SUA schedules from the Special Use Airspace Management System via the Harris Weather Data Services product that L3 Harris uses as the intermediate for ingesting the SUA data. The SUA data is filterable based on airspace type, and it is uplinked from FISB every 10 minutes as a text product. In its FISB cellular tier structure, we have a high, medium, and low set of tiers, as well as one for surface environments. And the bottom table, we're showing what the initially deployed SUA status look-ahead range was for SUA products, from the low tier of 250 nautical miles upwards to the high tier of 500 nautical miles. Today's current adaptation has all three tiers set to a 5 nautical mile look ahead, and we'll get to that in the upcoming slide, which were affected by the changes into the most recent FISB MOPS, the DO 358 Bravo. This next slide shows a typical text SUA message. This one is for a MOA report. We break out all the individual fields here and show the description name on the left there. On the next slide, the FISB avionics SUA status requirements are derived specifically from the RTCA DO 358B MOPS. The MOPS specifically requires that certified avionics exclude the SUA product from use, and Appendix H provides a rationale as to why, which, as noted here, the FISB SUA product is not an official source of the SUA status, and inconsistencies have been noted with the published SUA active hours and the SUA NOTAMs regarding status outside of active hours. Avionics systems certified under TSO C157B, which references the DO 358B MOPS, will not process or display the SUA status product. Only the SUA NOTAM-Ds are processed by these systems. Non-certified systems like Vfr Flight do display SUA status information from FISB. These are not certified to the TSO or the MOPS, but use the available FISB information to display product data to the pilots. Looking forward, potential FISB changes that could support the NDAA objective, we have broken down into two terms of time frame. The near term, we could reapply the look-ahead ranges for SUA status to what was originally deployed, which would then open back up the look-ahead ranges from 5 nautical miles up to the 250 to 500 for the corresponding tiers, filter out and only provide airspace types for uplink types with accurate status and schedule information. And some non-certified systems will be able to process this information today. On the longer term, we are looking at the possibility of adding a corresponding graphical SUA status product to the FISB service. This would require development of MOPS requirements, as well as changes to the ground-based infrastructure FISB service that L3 Harris provides to the FAA. Modification of the MOPS itself would need to occur to remove the prohibition on the use of SUA status information and add the graphical SUA status product if that were to be selected. Changes to certified avionics may add additional time to the availability date, as obviously manufacturers would then need to implement the changes and make available to the operators. And finally, on our last slide here, we provide an example output of what a graphical SUA status product could look like taking the previous MOA status as an example and providing two boxes here, one for an active and one for a waiting MOA.
Hello, my name is Davey Andrew. I'm the project manager for the Aeronautical Common Service. Currently, there are several types of aeronautical information that are provided by different FAA authoritative sources. The Aeronautical Common Service, or ACS, is a new system planned to be in production this fall. The ACS will collect and integrate aeronautical information from 5 of these authoritative sources. Focusing on special use airspace, the ACS collects both the static special use airspace definitions and special use airspace schedules as they are published. The static special use airspace definitions contain details on the airspace boundaries, altitude range, the general time of use, and the using and controlling agencies. Whereas the special use airspace schedules provide when individual special use airspace are scheduled day to day. For example, that a specific special use airspace will be active between 0800 and 1400 tomorrow. The ACS integrates the special use airspace schedules with the static special use airspace definitions and provided in the Aeronautical Information Exchange Model, or ATSM 5.1 format, to ACS consumer systems that have onboarded via SWIM. It's important to note that this ACS interface is not a human interface, but rather it is a system-to-system interface to provide the special use airspace information available to other systems. In conclusion, the ACS will provide our special use airspace information to consumer systems on SWIM beginning this fall.
Hello, everyone. I'm Alex Murray, presenting on behalf of the FAA's SWIM Program Office. I will be providing a brief update to get you more familiar with SWIM. If you have any questions, our contact information will be on the last slide. Quick overview of SWIM. SWIM stands for System-Wide Information Management. SWIM provides the messaging infrastructure, governance standards, and services needed to optimize the secure exchange of relevant data within the National Airspace System, also known as the NAS. SWIM provides a single point of access for the system-to-system exchange of real-time, relevant, and reliable information across the NAS. SWIM is the digital data sharing backbone of the FAA's NextGen initiative. NextGen is a series of interlinked programs, portfolios, systems, policies, and procedures that are implementing advanced technologies and capabilities to dramatically improve the operations of the NAS. Information services on SWIM. SWIM facilitates the exchange of information required to support all phases of flight. Information services on SWIM can be grouped into 4 main categories, including weather, flight and flow, aeronautical, and surveillance. Weather information services include products such as wind shear and microburst predictions, storm cell and lightning information, and terminal area winds aloft. Flight and flow includes information on flight plans, traffic management initiatives, and more. Aeronautical information includes NOTAMs, airport reference and configuration data, and special use airspace. Surveillance includes en route, terminal, and surface position data. Access to this information enables NAS users to make better decisions and improve the efficient use of airspace. SWIM facilitates the exchange of information. This is a conceptual snapshot of how SWIM facilitates the exchange of information in and out of the NAS. Here are the different categories of data we discussed. SWIM provides the enterprise infrastructure required to ensure successful and secure message delivery between systems. Users of SWIM data include mission partners, producers, and consumers. Users access SWIM through multiple mediums, including direct NAS access, the NAS Enterprise Security Gateway, or the public cloud. The NESG of the NAS Enterprise Security Gateway is SWIM's most secure entry point to access and exchange data with SWIM. SWIM's Cloud Distribution Service, SCDS, is a publicly accessible cloud-based infrastructure that makes the SWIM data available externally. A great benefit to SCDS is that new users can connect to SWIM quickly. In a few years, data will be accessed through the Enhanced SWIM Cloud Service, ESCS, which I will speak on in the next slide. If you're interested in connecting to SWIM, I'll let you know how to get started in a moment. The Enhanced SWIM Cloud Services. We are excited about the Enhanced SWIM Cloud Services. ESCS allows for bidirectional data exchange with airlines and other mission partners to enable operational usage in a cloud environment. This is unique because it is both cloud-based and bidirectional. Very exciting for the FAA. ESCS will quickly become the primary way that external operational users connect to SWIM in the next 3 to 4 years. ESCS will support more advanced business services and drive innovation. By putting data in the cloud and enhancing security, we can deliver the right information at the right time to pre-authenticated users that need it. It creates opportunities for users that parse and publish data in new ways. We are interested in how we can enhance SWIM to better meet your airspace data needs today and in the future. Get connected or involved. The SWIM Program Office has several ways for you as a stakeholder to get more information and stay up to date on the latest SWIM developments. Swift Portal is an exciting platform where SWIM users can learn more about and subscribe to the services that SWIM provides, collaborate on questions and solutions that contribute to a more efficiently run airspace. They can see real-time status of SWIM data services. Get help if they need it. Visit the link on the screen to see the Swift Portal. SWIM user forums are virtual meetings where you can hear the latest updates from the SWIM Program Office and provide your input and feedback directly to them. The next SWIM user forum is scheduled for October. Visit the user forum link on the screen for more information. Swift meetings promote the collaboration with airspace partners to innovate, solve common challenges, and improve system interoperability. We are planning the next Swift meeting for this fall in the October-November timeframe. Visit the link on the screen for more information. SWIM is preparing for the future with innovations that will enable the NAS to meet tomorrow's airspace users. You can reach the SWIM Program Manager, Kristen Croft, by emailing swim@faa.gov. My email address is also listed on the slide if you would like to contact me directly. Thank you again.
In this segment, we cover potential future data dissemination pathways of FISB and AIM-ACS via SWIM. As a reminder, contact Air Traffic Control for the current status of all special use airspace.
Welcome to the live question and answer session. This Q&A session will last for approximately 60 minutes. We are recording this workshop and it will be available on the FAA's YouTube, Facebook, and Twitter channels after the workshop concludes. Please share the link with others that are interested in this topic. This process will be collaborative, and the information we collect via this process will inform FAA and DoD decision-making. As we begin today, I think it's important to note that while we have a diverse audience, we may not have every user with us represented here today. One of our most significant challenges is weighing the needs and requests of all users while still finding the right balance. Now, a few housekeeping remarks. If you're having technical issues connecting to the workshop, you can text our tech support number anytime during the workshop at 949-678-0253. That's 949-678-0253. If you're streaming this workshop using Zoom, you may submit a question using the question and answer button located at the bottom of the screen. If you're streaming on Facebook or YouTube, there's a link to a form in the comments section to submit questions. As a reminder, the questions asked and answers provided here are not part of the public record. Now, finally, I'd like to introduce our panelists. From the FAA System Operations Services, Joe Dotterer. From FAA Mission Support Services, Paul Gallant. From FAA Air Traffic Services, Steve Hamowan. From FAA Next Gen Organization, Eldridge Frazier. From FAA Program Management Organization, we have Kevin Liu, Alex Murray, Andy Leone, and Bob Pomrink. And from the Department of Defense, we have Lieutenant Colonel Joe Turkle of the United States Marine Corps and Eric Ibe of the United States Air Force. Welcome to all our panelists. And before we dive into the questions and answers that were submitted, I want to talk a little bit about the data dissemination. It's easy to think of this type of notification like a TFR, a temporary flight restriction. However, there's a little more to it. As seen in the presentations, there are different types of airspace data, and that data is housed across DoD and FAA systems. And the data architecture we have today wasn't necessarily designed to accomplish what the legislation is directing. So we recognize that it's insufficient as is. And in addition to data architecture, data accuracy is of vital importance. Also, I want to talk a little bit about the FAA's mission of providing a safe and efficient airspace system. We need to ensure that that data transfer from the from the DoD to the FAA to NAS users is accurate every single time. And that data precision takes time. At this point, I'd like to open it up to Lieutenant Colonel Joe Turkle for additional remarks.
Thanks, Scott. Appreciate being part of the conversation today. And I would like to make some remarks just to sort of contrast TFRs from special use airspace. As you may know, TFRs are not defined as special use airspace and normally are scheduled and activated by the FAA for something like a special event. Other characteristics of TFRs that are different from special use airspaces, they're normally short in duration, say, for example, a 4-hour period. And also there's very few in number relative to the SUA that's being activated on a daily basis. The TFRs are normally activated, deactivated, aligned with their scheduled times. As you saw in the briefs, the special use airspace is not always activated, deactivated with aligned with the scheduled times. And then the TFRs are also promulgated via a NOTAM. SUA, so long as it's scheduled within its published hours, no NOTAM is promulgated. Now, excuse me, being part of the Tiger team that's looking at solutions, potential future solutions, we did interact with the FAA subject matter experts to see if NOTAMs for SUA is a feasible option to disseminate the information. And there were a couple of things. Number one, those NOTAMs are not currently generated, as I said. And number two, the NOTAM system was not set up to handle that volume of NOTAMs. So it was deemed not feasible. And that's part of the Tiger team's charter at this point, is to look at some other ways that the information is going to be disseminated.
Thank you, Lieutenant Colonel Turkle. Great points and great insight. So with that, let's dive into our first question. What are you doing about the data in the 2012 MITRE report that stated potential significant carbon emissions, time savings, and cost savings of $100 million a year? I think to answer this question, I will open it up to Kevin Liu.
Thanks, Scott. Since 2012, the FAA and DoD have made significant improvements on how DoD and FAA systems communicate. These enhancements enable a higher fidelity of scheduled SUA information on sua.faa.gov, which makes this data available to the public. The ability to know what SUA is scheduled during flight planning is a substantial portion of the potential savings mentioned in the 2012 report. This is mostly due to the opportunity for operators to plan to fly through SUA not scheduled for use and avoid loading the additional fuel that would be needed to fly around the active SUA. This information, as said, is available today on sua.faa.gov to assist with operators during flight planning.
Great, thank you, Kevin. I think it's important there to note that we have, you mentioned the Tiger team, we have the FAA and the DoD subject matter team put together, and we're looking at solutions to implement this legislation. On to our next question. What has FAA done with Nsap since 2012? I think I'll go back to Kevin for this answer.
Thanks again, Scott. Many things have changed within the NAS and technology since 2012. The joint FAA and DoD team analyzed the 2012 documents and found progress in many areas. For example, standardizing naming conventions for special use airspace, or progress with programs such as Aeronautical Information Management Modernization, or AIM, and its Aeronautical Common Services, also referred to as ACS, as well as FAA SWIM. The FAA is looking forward to continuing its effort to share MOA and restricted area status with NAS users and improving that in the future.
Great, thanks so much, Kevin. Our next question states, we also know that many of you in the audience want to know how soon to expect the FAA to be able to disseminate this real-time data. I think to answer this, I'll throw it first over to Andy Leone.
Yeah, thanks, Scott. So as we discussed earlier, I mean, the data itself and the architecture to disseminate it's complex. There's aspects on the ground as well as on the operator side in the cockpit relative to FISB. Making the data available also means that the avionics needs to be able to receive it and display it. And we're working through those options and the timelines associated with them.
Hey, thanks so much for the clarification, Andy. I think it's important to kind of foot stomp here the complexity of the data that we're seeing here with the different types of published, scheduled, activated, and utilized airspace data that you saw in the presentations, and also that the complexity of the data architecture that needs to run from the DoD to the FAA and out to the NAS users. So it's a complex issue we're trying to solve here. Appreciate that answer. Our next question coming in is if the results of this effort mean we'll have greater access to Moas in restricted areas. I think as Terry Bristol, the COO of air traffic for the FAA, mentioned in her opening remarks, this won't change the frequency with which military airspace becomes available, but will make information about that airspace more accessible and useful. So it's another tool in the toolbox for NAS users. On to our next question. SUA.faa.gov lists all scheduled SUAs, or special use airspace. Can this data be accessed via an API, an application programming interface, or something that allows two applications to communicate with each other by third parties? I think to answer this question, I'll throw it over to Kevin.
Thanks, Scott. So the ACS, which Davey presented on earlier, that is going to provide an interface out to third-party systems, and its data source is the same data source that feeds SUA.faa.gov. So the underlying information that feeds that website will also goes through the ACS and out to ACS users. And like I said, that goes to third-party systems on-ramp to SWIM, and I think I'll pass it to Alex to say a bit about SWIM systems on-ramping to SWIM.
Yeah, thank you, Kevin. So with on-ramping to SWIM, you'll have access to the ACS service through the web service functionality. Currently, that's done through the security gateways, which are a hardware VPN access. And like mentioned in the presentation, we're looking at deploying an enhanced cloud service that will then allow you to connect directly to those web services without the need for a VPN tunnel. So directly via TLS sessions, you'll be able to connect to the ACS service via the enhanced SWIM cloud service.
That's a great question and great answers, and I think it's good to reiterate here that really the plan is to make the data available to the public and available for third-party suppliers to kind of fill in the white space on how the information gets to the cockpit. So that's a great answer. Thanks for that. Moving on to our next question. Is there a plan to provide one source of real-time SUA status for both regularly scheduled and the activation, deactivation of SUA? I think we'll go back to Kevin for this one.
Thanks again, Scott. So the FAA, in coordination with the DoD, intends to augment the currently provided schedule times, as we've discussed. The schedule data is out on SUA.faa.gov and will be out in the future through ACS and through that FISB path. And so in coordination with the DoD, FAA is working towards also providing out the activation and deactivation status in the future.
Great, thanks for that clarification, Kevin. On to our next question. Is the DoD FAA team in a position to discuss its definition of real-time sharing of the information? I think we'll go back to Kevin. You're popular today, Kevin.
Yeah. I'll happy to answer another one. The goal is for the SUA schedules to go out, within acceptable delay tolerances as real-time information via automated means. So there'd be minimal delay to recipients, whether that be a controller on position, an operator conducting flight planning, or a pilot in the cockpit.
Great, Kevin, thank you for explaining that for us. On to our next question. Are there plans to integrate real-time status with popular EFBs, that's electronic flight bags, such as Vfr Flight? I think I can take this one. If the FAA disseminates a MOA or restricted area information via a means in which a third-party provider is able to access and or broadcast it, it'll be up to the provider to determine how the information looks and how often to refresh the information. Like I mentioned before, the DoD FAA's goal here is to make that, disseminate that information, make it available for NAS users for the legislation, and that's what we intend to do. On to our next question. What's going to happen next after this meeting? How will you continue to engage with industry? So I know that my voice will be heard. This is a great question, and I'll take this one too. We recognize that in order to implement the legislation, there are decisions to make and actions to take by FAA, by DoD, and by industry. As we stated in our written response to industry's request to participate in this process, we're committed to staying connected to ensure alignment between FAA and DoD and industry as these decisions get made. We view this event as the first step in engaging with industry to share details and perspectives on implementing the legislation. And we believe that connectivity between FAA, DoD, and industry representatives have been established, and we intend to keep those lines of communication open. So we look forward to working with the industry folks on this meeting today, moving forward. On to our next question. Will this presentation be made available to the participants? This is a great question. So this event is being recorded, which includes the presentation slides and all the answers here during the Q&A. And this entire presentation will be available on FAA's social media channels. And onto our next question. What exactly is the bottleneck in getting real-time special use airspace, special activity airspace data, which is activated, utilized data, out to industry? Is it getting that data from the DoD? Is it finding a way for controllers to enter the data into the system? Is the challenge technological, or is the challenge procedural? This is a really great question. I guess I'll start, and then I'll throw this over to Lieutenant Colonel Turkle. I think that we recognize, as we mentioned before, we recognize that in order to implement this legislation, there are decisions to make, policy, budgetary decisions to make by the FAA and the DoD, and actions to take by FAA, DoD, and industry in order to implement. And as we stated in our written response to industry's request to participate in this process of implementation, we're committed to staying connected to ensure alignment between FAA, DoD, and industry. I think at this point, I'll throw it over to Lieutenant Colonel Turkle, see if he has any insight on this.
Yeah, thanks, Scott. That is a great question. It gets to the heart of the problem here. And what I would say is, as far as DoD schedules, there is no bottleneck. We have the systems that Eric briefed at the beginning. They're different systems, but they provide to the FAA the schedule for DoD in a standardized version. So the schedules are not a problem. It's not a bottleneck. One of the main things that the Tiger team is working on is activation and deactivation. I stated before that SUA is not always the schedule, and the activation deactivation times are not always aligned. So that adds some complexity there. And as it stands right now, normally the activation deactivation status is known between the using agency and controlling agency. And it's contained on various ATC operational systems that right now are not automated with those scheduling systems and is not disseminated to the public. So that's the crux that's the bottleneck. It's a very complex problem that includes a lot of system interconnectivity and also some procedural stuff between DoD and FAA to standardize it to make sure that data is accurate. I'll throw it over to Eric Ibe, see if he's got any other comments from the DoD side.
No, sir. I think you about hit it on the head. No additional comments at this time.
Great, thanks so much for the addition. I think it is really important to kind of foot stomp that note that we're talking about integration of data architecture systems, and that can be complex and it can be time consuming. On to our next question. How can we get to standardized data schemes for NAV databases so FAA can indicate special activity airspace status via FISB. I think we'll open this up to any panelist who wants to jump in. Maybe look over to Andy to kick us off on the FISB portion of it.
Yes, Scott. So, I mean, existing FISB products, I mean, we do have an SUA status message, as indicated earlier, and it does go up in a text format up to the operators. Right now, it is limited, as I noted. The constraining factor right now is the avionics, right? In updating the MOPS to allow the avionics, certified avionics, to be able to display it. I guess the second piece of this would be whether or not we head down the path of introducing a graphical corresponding SUA status message as well for FISB to provide it to the avionics, and for the avionics manufacturers to then offer it up to the users to actually have that on their CDTIs.
In addition, Andy, RTCA has a standard for SAA data link capability on the data link, and that is DO364 that provides SAA status.
That's great. That's great information. Can I ask a little bit more information on a graphical SUA message? What that means? What that looks like? Maybe Andy or somebody else in the PMO.
Yeah, go ahead, Bob.
Well, the graphical message would look very similar to a TFR, right, on the pilot's display, and you know, it all has to be worked into the MOPS and things like that on the information that gets sent and how it gets displayed. But you have TFRs today that show up that give you an area where TFR is in effect, so the pilot knows not to enter that airspace. The TFR, I mean the SUA graphical product would look similar in that if there's an active SUA, MOA, or restricted area, it would be highlighted in a certain color, maybe red, to indicate that it is active. Or if it's scheduled for the future, we'll give a different indication saying this is scheduled for the future, it's not active now. So that's the concept, but we would, you know, welcome input from industry through RTCA as we develop the standards for the display of that information on avionics to the pilot.
It's very helpful, thank you. So it sounds like there's an established process to make these avionics upgrades. We hear the term MOPS a few times come up. Can I pull the thread a little bit on MOPS and maybe we can learn a little bit about what that means, what that is, and maybe a little bit about the process to update them?
I can start. Eldridge, you might want to fill in too, but the MOPS are the minimum operational performance standards or specifications for the development of avionics. So it includes members from the government, industry, DoD, FAA, manufacturer of avionics equipment, and they work on defining the detailed requirements for those avionics systems. And there's a DO358B MOPS that defines how to process and display FISB information. And there's also other MOPS for traffic information and things like that. Eldridge, did you have stuff to add?
Yeah, so as a committee, the special committee that's given authorization to do that MOPS is given by the RTCA Program Management Committee. We in SC206 have been given that authority to update, and we would have to go in with a terms of reference agreement to update to a C level. Right now we're DO358B, and to make any additions to that MOPS, we would have to go to a C. And to those that might be concerned, we do regression to make sure that A is still compatible to be in sea.
Thank you for the additional information. It's a lot more clear to me now, and I hope it's more clear to audience. There's an established process in place that we'll have to follow when we get to that point in the process. So thank you for those answers. Moving on to our next question. Is there any ongoing efforts toward the DoD adopting a single airspace scheduling tool for use by all services? I think I'll open this one up to Eric Ide.
Thank you, Scott. The short answer is no. And the reason why is simply because the DoD has no requirement for a joint airspace scheduling tool, nor has the DoD been requested by the FAA to develop a joint airspace scheduling tool. That's a simple answer. Let me expand on that some. So earlier in my topic 2 presentation, I stated that CSE, DCAST, and RFMIS are the systems used by the DoD to schedule special use airspace. What I didn't say was that each of these systems provide capabilities well beyond simple airspace scheduling. And a clear example of this can be found in RFMIS, which stands for Range Facility Management Support System. And as that name implies, it's a tool used to manage ranges and their resources. Now, can it schedule airspace with the FAA? Absolutely. But is that the limit of what it's used for? Absolutely not. And that goes for CSE and DCAS as well, because each of these systems were developed to meet the unique needs of their respective service, which go well beyond just scheduling airspace. And despite their differences, each system is fully capable of submitting the specific data that the FAA requires of the DoD to ensure complete visibility into our airspace scheduling requirements. And that happens every day, works quite well for all involved. So this is why the DoD has not developed a joint airspace scheduling system.
So great question and a great answer. Thank you for running that down for us. On to our next question. I was recently given, this is from a pilot, excellent. I was recently given an IFR clearance that routed us through active SUA. How can it be possible? We were rerouted by ATC, by our traffic control. I think I'll kick this over to our resident controller, over to Steve Homelin.
Thank you, Scott. If we go back to one of the presentations, I don't necessarily care which one, just so we can show a little graphic here. As airspace is activated, it's controlled by both a using and a controlling agency. So when it's active, the using agency is the one that's physically running the airspace and or aircraft that are in that airspace. But from a FAA ATC perspective, we're sitting there, and as we reroute aircraft around the airspace, we're also aware of what's going on. So we can easily coordinate for craft or aircraft to transition that airspace if a situation comes up, for which, say like an aircraft needs an expedited clearance to get through because of an emergency operation. But in a normal situation, as a controller is sitting there watching the airspace, they'll see that the potential is there for there to be 0 aircraft being used in the airspace. So they can go ahead and coordinate. This is perfect. So when the airspace is activated, it just means that from a controller standpoint, I know that the airspace is going to be used, but I can watch it and I can see whether or not the airspace is actually being utilized at that time. And if I'm noticing that there's really no aircraft in there, or potentially no aircraft scheduled over the next 15 minutes, as I've got an aircraft approaching, in this case, the Moody Moas, I can potentially reroute the aircraft through the activated airspace by coordinating with the using agency, and then be able to provide that kind of a service to an aircraft to get them a shortcut, to get them along their route of flight and on their destination in a quicker manner, as compared to always making an assumption that because an airspace has been activated, that it's actually in use at that time or being utilized. So the other part of it to remember is that as a pilot, if you're sitting there and you're seeing and you're potentially have been rerouted around a special use airspace, don't be afraid to ask the controller if, hey, I'm coming up on Moody MOA. Am I available to get a shortcut back through the airspace? The controller will do the research, and they will end up coming up with an answer for you by coordinating with the using agency to find out if we can take one aircraft through the airspace to potentially help the pilot. All of our facilities between the FAA and the DoD, we've got good processes in place and good personal relationships between our counterparts, so that making a phone call like that for an aircraft, it's not something that is not unusual. And it's a tool that we as controllers probably don't utilize as much as we can. And I will turn it back over to Scott.
Steve, thanks for that really in-depth response. A very technical question and a great technical response. I think the things to kind of reiterate here, based on your answer, is really see the fluidity of aircraft operations. Decisions are made in real time by controllers based on existing traffic, and it's also a good reminder to contact ATC. Sometimes that can help with the efficiency of your flight. So thanks for that answer. On to our next question. Based on the 180-day requirement to implement the 1085 legislation, what are the DoD and FAA's plans to make this happen? I'll take this answer. Like we briefed in the presentation opening remarks, we've established a Tiger team between the FAA and the DoD, and we're taking the necessary steps to the maximum extent practicable to implement Section 1085 and enable the dissemination of the information. We also believe that bringing industry to the table is very important. That's why we put this event on today, and we'll be continuing communication with industry in the days and weeks following this event. Great question. And on to our next question. Will the planned display of airspace status be part of the data that's streamed to the aircraft via ADS-B? I think to answer this question, I'll open it up to Andy.
Sure, Scott. So if the FAA disseminates the MOA or the restricted area information, which in this case here would be via FIS-B, it really would be up to the receiver, in the avionics that the manufacturer would define as to how it would be displayed and the manner in which it is updated, how frequently the CDTI in the cockpit would be updated. We would be disseminating the data on a given frequency, but then it's up to the avionics and how it is managing all of its input data from all the other FIS-B products and how they would be represented to the pilot.
It's a great answer. Thanks so much for that. Is it possible to stay on this question just for a bit longer? Sure. and maybe give a very, very high level description of what ADS-B is for the folks in the crowd that may not know?
Sure. So, I mean, there's a number of products that really are built on top of ADS-B, automatic dependent surveillance broadcast, right? So aircraft that are equipped and mandated to be equipped in rural airspace to provide ADS-B information, it's the aircraft taking GPS-derived navigational position and broadcasting it out. And it's being broadcast out over two different data links, whether it be on 1090 extended squitter or on the universal access transceiver data link on 978. And this provides data both to air traffic control and the ground system, and to other aircraft for situational awareness. It's then, there's complementary services. We've got ADSR, which is ADSB rebroadcast, which does a cross link between the two different data links for aircraft to have situational awareness for aircraft that are on another data link if their ADSB in capability is only on one of those links. A third product is the traffic information services, which the ground infrastructure will assist the aircraft in seeing aircraft in its proximity that aren't ADSB equipped. So we are taking other surveillance sources such as radar, and if an ADSB equipped aircraft is ADSB in equipped, the ground system will then build a what we call a hockey puck and provide that information up to them to give them a complete traffic picture around them. And then the fourth service here would be the flight information services broadcast, which we're talking about here is, SUA status is one of, created the whole list in my presentation. There are a number of text products, and we've also got some graphical products such as CONUS and regional weather. So they all fit together as a number of services for pilots and for air traffic for managing airspace.
Thanks, Andy, for clarifying that. Really good rundown on ADSB. I think we see that it allows air traffic control to see where aircraft are, to surveil aircraft using non-ground-based technologies, and also potentially gives aircraft information on other aircraft. So thanks for the rundown. Appreciate that. On to our next question. Is adhering to the statutory requirement a top priority for the FAA and DoD? I think, like mentioned before, we're taking steps, bringing two organizations together to find ways to implement this. It has the highest visibility and support within FAA and DoD, as we saw from our opening remarks for today's event. And we recognize that this is just the first step. This meeting is just the first step in engaging with industry to continue working to implement it. So yeah, we view it as a top priority. That's from the FAA perspective. I can open up to Lieutenant Colonel Turkle to see if he has any thoughts from the DoD perspective.
Yeah, thanks, Scott. I would echo your comments in that, and I think if the attendees were here for the opening comments, they would have seen Brigadier General Maury talk about a memorandum of understanding between the DoD and the FAA, and about the sort of unprecedented collaboration that's going on between the two organizations right now. And certainly Section 1085 is squarely in the middle of that. So this effort has full support and collaboration by the DoD, and will continue to be part of the Tiger Team and look for the solutions.
Thanks for those remarks. On to our next question. The TFR, or temporary flight restriction language included in the statutory requirement, was included in the provision to suggest getting the real-time status of Moas, special use airspace, into the cockpit, and not so much using the same transmission data. Seems to me that this is more of a statement that maybe we can open up to the panel to have a discussion on, maybe starting with Lieutenant Colonel Turkle, and then see if anybody else wants to chime in on TFR and data dissemination.
Yeah, I appreciate the question coming on the clarification of the TFR language, and so it's certainly understood that it's the TFR language is used as an example of the type of dissemination that pilots and NAS users would like to see on SUA, specifically in this legislation, restricted areas and Moas. So that's understood, but I think it's come up several times, and I guess I'll talk to it again. The scheduled data is a little easier to disseminate than the activation deactivation time. The scheduled data is already there. It's already disseminated via sua.faa.gov. So it's open and available to the public right now. And in fact, we've taken a look at some former studies done by MITRE and so forth that basically shows the dollar savings that pilots or industry could achieve by doing their flight planning based on those schedules, by the published time. So that information is out there. Now, when you talk about the activation and deactivation, I've also stated that those two events, meaning the scheduling and the activation, deactivation, are not always simultaneous. There could be instances where it's necessary for them to be different. The training mission could get delayed. There could be maintenance issues. There could be issues like that. And the using agency and controlling agencies are often in good communication. And in that case, if the DoD does not, if it's scheduled and the DoD does not need it yet or can't occupy it, they would coordinate with the controlling agency and allow them to continue to route traffic through there. So there's many circumstances like that. And I would just say this, if you think about the complexity of the cockpit, the real-time activation, deactivation of special use airspace. You can imagine pilots using that information to navigate and possibly not even talk to air traffic control. You also must imagine how ironclad safe that system will have to be before that information is disseminated and pilots feel comfortable in using it. So it's going to be a complex effort. There's a lot of systems involved. There's a lot of procedures involved, and they've got to be safe. So thanks for that question.
Thank you, and thank you for clarifying remarks. Really appreciate that. I think I'll pause just for 3 to 5 seconds to allow any of the other panelists who may want to unkey and add something to this question.
Sure, Scott, Erica. So it's also important to remember, and what is a TFR? TFR is essentially just a NOTAM. If we were to disseminate the status of special use airspace in the same manner as we disseminated TFR, it essentially crashed the NOTAM system. The Air Force alone has well over 400 pieces of airspace that go active and inactive throughout the day. So as Lieutenant Colonel Turkle said, it's important to figure out what systems are resident within the FAA that contain those key data points that we need, and then figure out how to do that interface to get that data out into the cockpits.
Eric, great points. Great points. Thanks for adding those.
And Scott, if I may.
Steve, please go ahead.
To follow up on Eric's point about the TFRs, if you sit there and in terms of if you sit there and you look at the SUA website, and then you go to like the NOTAMs website, in which you can do, it's off of, you can Google FAA NOTAM search to do it. It's fairly easy. You'll see that on a typical day, we've got somewhere in the neighborhood of 1,500 or more NOTAMs that are out there for within the NAS. Okay, and that's just doing a quick search off of it, and that's not going to include scheduled SUAs. I should say not scheduled SUAs. That's not going to include published SUA information, because those don't get NOTAMed out. Now, and then to bring up something that Lieutenant Colonel Turkle mentioned, when you're sitting there and you're doing your flight scheduling, and you're looking at potentially you're planning your flight, you know it's going to be a 3-hour flight. You're looking at potentially over this leg, you're going to enter a special use airspace, we'll call it, at 1 o'clock in the afternoon, wherever you're at. And then you notice that by the time you transition that special use airspace, that the airspace is going to be active before you exit it. I would recommend don't be afraid to go ahead in that situation, provided you depart on time. Plan on your flight being able to fly through that SUA, because when you initially hit the SUA airspace, the SUA won't be active at that time. And then as controllers, as we know that SUA airspace is going to be going active, as that activation gets coordinated, we'll talk with the DoD or other entities involved, and say, hey, reference, and I'm just going to say American One for an aircraft. Hey, reference American One, he's still at 17,000 feet eastbound transition in the airspace, and just watch that aircraft. And then like, once that aircraft transitions out, in this situation, then the SUA will go active for that airspace that that aircraft was in. So don't be afraid to plan your flight through the SUA if you're going to hit the SUA before it goes active. But also don't be surprised if you're getting close to it and say that the airspace ends up going active a little bit earlier. You might end up getting rerouted for it. Or that as you're transitioning through it towards the end, the possibility is there that ATC is going to ask you to change altitudes to help accommodate the using agency, but that's not usually something that will happen. Back to you, Scott.
Thanks, Steve. Really great points, and thank you for kind of adding that the operational picture to it. Really kind of paints a really good picture there. I'll pause and see if there are any other panelists that want to jump in on this question, and if not, we'll move on to the next one. So 3 to 5 seconds. Okay, we'll move on to the next question. This one I think is gonna go back to Steve. Is calling the center the best way to figure out if a MOA is hot?
Well, thanks, Scott. I'll put it as yes and no. It depends on your status as an aircraft. If you are already talking with ATC via normal IFR flight, or if you're doing VFR flight following, then the best way to get that up-to-date information is to ask the person you're talking to right then and there. If you are a VFR flight who's out there and not taking advantage of getting VFR flight following, then generally speaking, you're going to want to, depending on where you're at within the country, and you would know that better as a pilot, where you're at and potentially what facilities around you. Trying to talk to the center is going to be one of the avenues that you can use to get updated SUA information. The other part of it would be is that if you know that you're near a TRACON or an approach control, go ahead and talk to them also, because they would end up potentially having information more pertinent to you being within their airspace. And generally speaking, unless you're within the airspace of a Class B a tower or facility, the approach controls are, like I said, generally speaking, going to be a little bit slower in terms of how many transitions are on the air that have to be responded to as compared to the center. Scott?
Great, thanks, Steve. Great question and great answer. Contact ATC. On to our next question. What APIs will be made available to the public for getting real-time SUA status? I think for this one, we'll go to Alex Murray.
Yes, thank you. So real-time SUA status is provided by sua.faa.gov, the same source that provides the SUA information to the ACS service. And so for information on the actual SUA status, we're looking for opportunities to make that available. And SWIM is one of those areas where that SUA information through the ACS service is available, will be available.
Great, thank you, Alex. Appreciate that.
You're welcome.
Scott, can I jump in on this one for a second? Sure.
Absolutely.
So I'll make a clarification that the sua.faa.gov isn't providing that data to the ACS. It's the system that provides, that's the source of the data for the website, is the same source as the ACS, which is the Special Use Airspace Management System, or SAMS. And also that, if they're going to referencing the real-time status as more than schedules, today it's schedules via that path. and that goes out and it's for that that interface provided by the ACS. It's reliant on SAMs to provide out that activated, deactivated status, which currently does not, but there are plans to for the future.
Kevin, thanks for adding that clarification. And I think based on that, it's another good opportunity to kind of pause and look and see how complex the data architecture is. They were talking about multiple systems that across the DoD and the FAA that have to be fully integrated, and that takes time. So really appreciate the clarification there. And then on to our next question. What is a Tiger Team? I think I'll start with this. A Tiger Team is a team formed for a special purpose, normally for a limited amount of time. In this case, the teams that we mentioned earlier is looking at the tactical management of special use airspace. And in this, for this purpose, is focusing on Moas and restricted areas per the legislation. I'll open it up to Lieutenant Colonel Turkle if he has anything to add on the Tiger Team front.
Yeah, thanks, Scott. And specifically, Scott leads the Tiger Team, which has subgroups, one of which I'm a co-lead with the FAA co-lead. And as he stated, it is the tactical management of special use airspace. And in this team, we have brought together for a short-term basis subject matter experts from every service, military service, along with experts from the FAA in airspace and also in the systems. And lastly, we have a contract team that helps us to pull it all together and also brings us a lot of knowledge base with it. So it is short term, and we at the end of it, we aim to provide through the FAA and DoD the proposed solutions to enact the legislation.
Great, thank you for adding that information. Now we know Tiger Team is more than just a jungle cat. We appreciate that. Okay, on to our next question. While the pipeline options, SWIM ACS and FISB, the issue of scheduled versus activated or real-time status has not been addressed. We don't need scheduled data to the cockpit. We need real-time status. How will FAA ensure the data set is real-time activated status? This is a great question. The DoD currently provides their SUA schedule to the FAA, as we laid out in the presentation. The FAA currently shares real-time scheduling data to the NAS users via sua.faa.gov. The real-time airspace status is known primarily only by the controlling and the using agencies. The current FAA DoD Tiger Team that we just discussed and we've been talking about a lot today, the effort there is to identify gaps in the shortfalls in the current automation systems and in procedures that, when acted upon, FAA will have the capability to disseminate that real-time airspace status to the cockpit. Like we've talked about throughout the day, that effort is complex. It involves system-wide changes and investments in time, investment in budget. So absolutely, the goal is the real-time status to the cockpit, but based on the complexities that we've been discussing here today and the requirements for accurate on-time data, that's a goal that takes some time to achieve. I'll pause and see if there's anybody else on the panel that wants to address this question. 3 to 5 seconds.
Yeah, Scott, I'll chime in a little bit there. Just to reiterate, yes, as an interim step, we are working to push and disseminate the schedule directly to the cockpit. That's an interim step, and I think the team believes it can be done more quickly than the actual activation deactivation time. And I'd like to really reiterate to all the pilots and industry out there that the major savings that could be achieved right now today. If you use sua.faa.gov and you do your flight planning based on scheduled SUA data Vice published, you would save considerable amount of dollars in fuel and other things. So I encourage all of them to start using that website to plan your routes. Beyond that, we understand that publishing the activation, deactivation time, real use is the goal to the cockpit. In that scenario, the pilot en route could ask for adjustments, just like Steve had indicated. The pilot would see that the airspace that may have been scheduled is not active or deactive, or sorry, activated. So it would be easy to ask for those adjustments, and there would be savings in the air. So we understand that, and that really is our goal to get to that point. However, I also stated the complexity of it, and also the imperative nature to get that information accurate, so that pilots have usable information in the National Airspace System.
Turgle, all great points, and thank you for adding those. We appreciate that. On to our next question. Most of the conversation has been focused around altitudes below Class A airspace, that's below 18,000 feet. How about above 18,000 feet, where airliners typically cruise? Do ATCAs, that's air traffic control assigned airspace, do ATCAs have the same scheduled, activated, utilized framework as Moas? Are there any differences in how airspace users are or can be notified when those areas are activated? That's talking about ATCAs. As users try to route flights more efficiently, it becomes increasingly important to know ahead of time when these areas will be available. I think there are a few panelists that can chime in on this. We'll start with Steve. Over to you, sir.
Thanks, Scott. Like Scott said, an ATCA is an air traffic controlled assigned airspace. And in terms of how it's scheduled and everything else like that, I'm going to refer to it as there's two parts here. One is that there's the regulatory part. Sorry, there's actually three parts. There's the regulatory part, there's the scheduling part of it, and then there's also, as the controller sees, an ATCA part of it. I am most definitely going to skip the regulatory part of it. In terms of it being scheduled, the way the FAA sees it is that we get it, is that from, for an ATCA, first off, ATCAs can both be set up by and used by military operators. It can also be set up and used by civilian operators. In terms of the way in which DoD schedules it, they end up putting it through their normal systems that they use. It comes into the FAA systems through our normal channels, and then it gets disseminated like we would disseminate a MOA or a restricted area. In terms of the way in which a controller is going to work with and around an ATCA, they're going to do it the same way in which they do it with a MOA. They're going to try to use vectors and or jet airways or Victor Airways to get the aircraft around the ATCA efficiently. And if we know that the ATCA is going to be going active and you're going to get there after it goes active, we're going to try to reroute you around that airspace as early as we can, so we're not, as we would put it, so we're not driving you directly into the ATCA and then having to use extreme vectors to get you around the airspace. So we don't necessarily have an airspace violation, and that your aircraft does not violate the active ATC assigned airspace. The other part of it is that often when an ATCA goes active, if you're in the middle of it, we'll also go ahead and get an exemption for you to finish your flight through that ATCA. And then as you get clear of the ATCA, the using entity will be able to to use more of their available airspace. And then I will, I guess I will turn it over to Eric next. If he's
Sure.
got any-
So from the DoD perspective, an ATCA is largely used as an upper extension of a MOA, so below flight level 180. In terms of the scheduling, like Steve just said, yes, we push those schedules through our respective systems, in this case, CSE, DCAST, RIFMIS. In terms of activation actually utilized, the DoD doesn't push any of that data. We push the scheduled data only, goes up through our resident systems, gets fed into MAID SAMs, both of which are is an FAA system. And then again, the actual activation times is largely a product of ATC, namely the controlling agency releasing the airspace to the using agency. That's what generates those activation times. And those times are largely resident within FAA systems. So the challenge is identifying which systems that information is resident in, and then again, making that linkage between those systems to the output into the cockpit. And that's the challenge that we're trying to address.
Yeah, Eric, and I'd add one more thing. The ATCAs, if you're a pilot, you may know, and others may know that it's not carded. So I just want to give one more push though for the sua.faa.gov. So the ATCAs schedules are, and with a disclaimer, not all ATCAs are disseminated via that website, but most are. So this is a great resource that you would be able to see which ATCAs are scheduled, and you know, so, and you wouldn't be able to get that information off of a VFR sectional.
Great information, great question, a really good in-depth answer. I'll pause another 3 to 5 seconds to see if there are any other panelists that want to chime in on ATCAs and ATCAs versus MOAs. Okay, with that, we'll move on to the next question. As a question concerning MTRs, which are military training routes. For many years, it has been difficult for GA, general aviation pilots, and flight instructors to determine the real-time status of MTRs. The recommended procedure is to contact the nearest flight service station within 100 nautical miles of the MTRs of interest. There are 2 problems with this. First, many flight service stations have been consolidated into automated flight service stations. And secondly, I get the impression that the users of MTRs may not be notifying the flight service station. Therefore, the flight service station cannot in turn notify pilots. This creates a disconnect that produces a real safety concern. Will real-time notification of use of MTRs be addressed? If not, what is the recommended procedure for pilots and flight instructors to obtain this critical information? I think a few panelists can chime in on this. We'll start with Steve, and then we'll open it up to other panelists.
Thanks, Scott. So for military training routes, unfortunately, the easiest way to get the information would be to contact ATC. Probably the easiest way to get that information from ATC, especially if you're at a flight training school that is a towered airport, is go and talk to the airport authority or talk to the air traffic manager of that facility and see if you can't work out what's called a letter of agreement, in which the facility knows about a military training route, so that when a military training route gets activated, the tower that you're operating out of gets told about this military training route, and then as you're getting your clearance, you should be able to ask the tower right then and there if such and such a military training route is active or inactive. Otherwise, unfortunately, the only real way to get this real-time information right now is going to be via calling your nearest center and or approach control to get that information.
Thanks, Steve. Good answer to a good question. I think I'll take an opportunity to kind of foot stomp that really the scope of what the Tiger team is looking at is focused on special use airspace. The scope of this conversation today is restricted areas and Moas, but we're not moving forward. We're not just closing the door on potentially expanding it to include modernizing the processes for other airspace such as MTRs. Those are still under review, and decisions need to be made on whether to expand beyond restricted areas and Moas. Before we move on to the next question, I'll pause for 3 to 5 seconds, see if there are any panelists that want to chime in on this.
Sure, Scott, I'll take this as well. So the method of scheduling MTRs within the DoD vary amongst the services. It even varies within the Air Force. CSE, as our mandated scheduling tool for airspace, previously did not mandate the scheduling of MTRs through CSE. So some units would use different methods to get those schedules up to the FAA. We've recognized the inefficiency in that, and we have made an effort through the publication of our latest regulation to get our units on board with using CSE as the primary scheduling tool for MTRs. And we've also considered or have looked into expanding that to other volumes of airspace as well, so that we can get that consolidated scheduling tool to take in those schedules of those pieces of airspace and then get them submitted into the FAA via a common manner as opposed to differing methods.
Eric, thanks for the additional information. Appreciate that. We'll move on to the next question. One of the challenges from an airline flight planning perspective is that there is not one up-to-date source of activated, utilized SUAs. When could the status be made available to flight planning systems? I think for this one, I'll open it up to Kevin.
Sure, Scott. So I guess, as discussed earlier, the ACS is, an interface for system to system. So our goal is to provide out the data that we get from SAMS, so that schedule data, in the future, that activation data from SAMS, and get it out to third-party systems such as other airlines. And I realize that I think I might let somebody else speak about the utilized, but currently that's not going to be going out through ACS. When the ACS comes out this fall, it'll be initially schedule data going out. And as the source for the ACS provides out updated information or new information, the ACS will provide that out to third-party systems, such as airlines.
Great, thanks, Kevin. And I think it's important to note that a lot of what we've talked about today and what you're hearing is a phased approach to meeting the intent of the legislation, starting with how do we do scheduled data better, and then moving on to how do we get that real time information into the cockpit. So Kevin, thank you. On to our next question. What methods are being used to protect the transition of military aircraft to and from the SUA and prevent a mid-air collision? So we'll open this up to Steve.
Thanks, Scott. So between the FAA and DoD, we've got procedures in place to ensure the orderly transition into and out of your SUAs for participating aircraft. What that means is that as somebody departs off of, in our example earlier, departs off of Moody Air Force Base, and they're going to go into either the R3008 complex or go into the Moody Moas. As they transition off the airport and they head towards the SUA airspace, okay, they are not going to do any of their combat maneuvering or other potential training items that they would end up wanting to conduct within the SUA. That's what the SUA is for. So as the aircraft is transitioning from the airport to the SUA, the aircraft is going to be treated as a normal IFR flight. Okay, so they're going to end up getting standard ATC services from everybody. Traffic advisory is going to be called, and they will get normal separation procedures. One thing to note is that often when an SUA goes active, we're not talking about a single aircraft going into that SUA. We're talking about what's called a flight of aircraft going in there. And so you can see, and I'll pick on them because everybody knows them. You'll see like the Blue Angels going out there and doing their flights, and you will see them in their formation. And we've got rules and regulations for how they are supposed to conduct themselves in that formation flight as they transition from the airport into the SUA. Scott?
Thanks, Steve. Great answer. There's rules and regulations for safe aircraft operations. It's a great answer. Thanks. On to our next question. What can industry do, or what does FAA DoD need to help expedite this effort to meet the intent of the statutory requirement? I think I'll open this up to Andy.
Sure, Scott, I'll take a crack at it here. So at least from the FISB solution set perspective, the FAA intends to continue to collaborate our relationship with industry, which would be through the RTCA process, to enhance their ability to receive and process the MOA and restricted area status information once it becomes available. And as we briefed earlier, making the data available on the data stream, up to the aircraft is just one step. The ability of the avionics to process the data and display it, whether it's in a text form or in a future graphical form, requires the MOPS standards to be updated to create this specification for it, and then software to be developed and implemented by the manufacturers and made available to the operators. So it's a multi-step phased approach that you can only push it so fast, right? And there's again, there's getting through those standards, getting them formally approved, and then to do the software, to do the testing, to get it recertified, and then out there to the operators. But it's working collaboratively with them and getting it into that forum and moving it through.
Great, thanks, Andy. And I'll add that while FISB is a proposed interim solution, we're going to continue our collaborative relationship to look at all potential solutions moving forward. So appreciate that answer. Mm-hmm. Onto our next question. What should pilots do if they enter into an uncharted MOA and don't know it? We'll kick this over to Steve.
Thanks again, Scott. First thing I'll say is contact ATC, because we should know the confines of the MOA and the activation, deactivation status of that MOA. Granted, temporary MOAs are not charted, but they are published on the FAA's domestic notices website. And sometimes we all know that human factors are prevalent, and that sometimes errors do happen. What I'd like to encourage people is that if you're a VFR aircraft, you're still allowed to be in that MOA, okay, whether it's temporary or not. Whereas if it's a restricted area, it doesn't matter what type, if it's an active restricted area, it doesn't matter what type of aircraft you are, you're not allowed in it unless you're part of the mission going into the restricted area. The other thing I'd like to say is that probably if you're in a temporary MOA and you didn't know about the MOA, and that you realize that you have military activity going on around you, I would hypothesize that you've potentially just seen the aircraft around and didn't realize that you were in a MOA. And so if you're sitting there and you think that you've had a potential safety event, or that probably your safety has been impacted, or potentially the safety of military aircraft within the MOA, contact ATC. Either write that in there if you can, or when you land, because if it's a question of safety, we take every instance of potential safety concerns very seriously, and we want to investigate it and find out what was going on. And if we find out in this case for a temporary MOA that somehow the information didn't necessarily get out to the public, that's something we want to know, so that we can correct that and keep the aircraft in the NAS safe. Scott?
Great, Steve. Thanks so much for those details. Appreciate that.
Hey, Scott, could I just do a quick follow-up on that?
Hey.
FISB has been sending up graphic and textual products for temporary MOAs and temporary restricted areas since the spring of 2020. So if you do have the ability to receive FISB, you will be able to see temporary MOAs and temporary restricted areas on your avionics or on your portable device. I just want people to know that.
Great, thanks for the clarification. Appreciate that. On to our next question. Current FISB SUA data does not include activation times, correct? Only schedule times. I believe this one is for Andy.
Yes, Scott, that's correct. FISB currently has the ability to transmit scheduled data.
Great, thanks so much. I know we've got a few more questions rolling in. We're coming up on our 1:30 stop time, but we have a few more questions we're gonna roll through. So on to our next one. MOAs, SUAs are either active or not active. What is the issue with DoD providing that real-time status and putting that into a transmissible form? Seems this is being construed as overcomplicated. So I think first I'll open it up to Kevin, and then we'll see if the DoD want to weigh in there.
Sure thing. So as we saw in the earlier presentation, that chain of getting SAA or SUA data out to the NAS involves many systems. So the challenge really is in the automations and the systems integration to get that out to NAS users. As Terry mentioned in the introduction, that it's not as simple as flipping a switch or a quick implementation.
Yeah, Scott, I'd like to jump on that a little bit too, from the DoD perspective. Just to clarify and correct the question, it's the FAA that activates and deactivates the airspace. So yes, it's a coordination between the using agency and the controlling agency, but it's the controlling agency that activates and deactivates the special use airspace. That information then is in operational systems that don't connect to the scheduling system, and the scheduling system is what we're looking at right now as a venue to disseminate that information. So again, a complex web of automated systems that needs to be solved.
Great question and great answers. Thank you, Kevin and Lieutenant Colonel Turpin. On to our next Question. Appreciate Lieutenant Colonel Turkle's comments. How does activation and deactivation of SUA happen today? What changes once processes are put in place other than providing the status in real time? I think this is kind of related to the last question, but I'll open it back up to Lieutenant Colonel Turkle.
Yeah, good timing on that question. It allows me to expand on the answer. So as it stands today, activation and deactivation is done with different methodologies, but the primary thing that folks should know is that there is a specific letter of agreement between every using agency and every controlling agency out there, and it dictates exactly how that airspace is going to be activated and deactivated. In some cases, it may state that it's activated, deactivated via schedule. So that would be similar to a TFR. In other cases, it's real-time coordination between the using agency and the controlling agency. So different methodologies based on the mission needs of the military and also based on the airspace needs and the surrounding mass. So, for example, there are areas, and I think you saw if you were here for the presentations, you saw 29 Palms that's right in the middle of the ascent into the LA basin. So within that LOA, the FAA had to account for weather. So there are stipulations in there that if weather is of such a nature, that the SUA can only be activated to a certain level. So the short answer is the activation deactivation is ultimately done by the controlling agency, and it is usually presented on their scope. And the using agency and the controlling agency have that information. It is not connected to dissemination systems right now.
Hey, thanks for that answer. It really kind of shows the like we keep talking about today, the complexity of the data and also data architecture system. So it's not just a matter of kind of turning on the faucet and let the information flow. We're moving into our last question that we have time for today. When will we know this program is available, and how will the FAA get out the information to pilots? I think we're going to be working collaboratively with industry representatives through the course of implementing this. When we talk about the long-term implementation plan on the interim fix and the potential to use FISB, I can open up to Andy to talk briefly about processes we use to update avionics, and then we'll be closing out today's meeting.
Yes, Scott, and yeah, to cap it off, as we said, I mean, there's three parts here. One is the ground system, and again, this would be the FISB in the interim. Is the changes that we would implement on the FISB ground system. The second piece, and this is where industry and pilots would need to focus in on, is the work that will then happen in the RTCA subgroup on the updates to the MOPS and the timing of that, and then with your individual equipment manufacturers as their timeline for implementing those MOPS and when they would be available to the pilots to upgrade their software.
Great, thank you, Andy. So
right on 1:30.
Right on 1:30. So I want to thank all the panelists for their time and their expertise today. Really appreciate it. This concludes today's Industry Day on Special Use Airspace Status. On behalf of the Federal Aviation Administration and the Department of Defense, thank you for joining us at today's event. This has been a very valuable discussion, and the dialogue here today will inform how we move forward. We have many various needs across the stakeholder community. It will be important that the solution speaks to those broad interests. The perspectives we shared today will assist with implementing this legislation, and we look forward to continuing the conversation as we collectively work towards solutions. As a reminder, today's Industry Day has been recorded and will be available on the Federal Aviation Administration's YouTube, Facebook, and Twitter pages. Thank you once again for joining us at today's event, and have a great day.